In this video, we're going to look at z-scores and areas under the curve. The National Sleep Foundation recommends that adults between 18 to 64 years of age sleep between 7 and 9 hours per night. A researcher collected data on the amount of sleep that students in college slept per night. The data were approximately normally distributed, with a mean of 7.8 hours and a standard deviation of 1.3 hours, as shown in the diagram below. So to help us visualize this problem, we have the normal distribution with the mean and standard deviation labeled. We are asked to find the z-scores for the boundary values of the problem below and make a rough sketch of the area under the standard normal curve you are finding. Then use the online normal distribution to find the requested percentages or probabilities. Okay, so let's look at the first one. We're asked what percent of students in the study slept between 8 hours and 9 hours per night. Okay, so this is going to be our boundary values. Okay, and I'm just going to make a very rough sketch. A little bit more than here and a little bit less than here. Okay, so we want to find this I'm sorry, that looks terrible. I can't draw a line, but you know what I mean. We want to find this corresponding area under the curve. Okay. Now to do this, we're going to find the z-scores, okay, which apply to the standard normal distribution, and then we're going to use this online normal distribution calculator to find this area. So remember, since this area, this is a curve instead of a line, we could approximate it with a trapezoid, but we generally use calculus or numerical methods to find areas like this. So we're going to use the online calculator to do this. But first we need to find these z-scores. So we know that 7.8 is the mean, so that's 0 standard deviations above the mean. 9.1 is 1 standard deviation above the mean. So our z-scores are both going to lie between 0 and 1, but we want to find them exactly. So first, let's write 8 hours. It's good to label what you're finding. Z equals, okay, well, we take our data value, we subtract the mean of 7.8, and we divide by the standard deviation. Okay, so this is 0.2 above the mean, and how many standard deviations is that? We'll just put the whole thing in. So 1 minus 7.8, okay, that's 0.2, and divide by standard deviation to find how many standard deviations it is. And we are always going to round these to 2 decimal places, so this would be 0.15. So this is approximately 0.15 standard deviations above the mean. Now let's do 9 hours. So z equals 9 minus 7.8 over 1.3. So that's going to be, well, the difference from the mean is 1.2 standard deviations above the mean, and divided by 1.3, so it's almost 1, which we saw in our diagram. And to 2 decimal places, we have 0.92. Okay, now we're going to go to the normal calculator. So here's our normal calculator. The mean is set to 0 and the standard deviation is 1 because that's the standard normal curve. And we have 4 options here: above, below, between, and outside. So our values were between. Okay, all of these are set to 1.96. You don't need to change all of them. You can just change the one that you're using. Okay, and we had 0.15 was our lower z value, and 0.92 was our upper z value. Okay, you don't have to put in the zeros, but it helps you see your decimal place better. Then once you do that, I think it already, no, it didn't calculate it. Calculate, okay. So this area is written as a decimal to 4 decimal places. Since we're going to write it as a percent, we multiply by 100 or move 2 decimal places to the right. Also notice up here on the curve, it's the same place, and it looks like we we set up all of our parameters correctly to get the area we wanted. So our answer is 26.16%. So 26.16% of students in the study slept between 8 and 9 hours per night. Okay, let's look at the next one. We are asked what percent of students in the study slept less than 7 hours per night. So 7 hours, it's about here-ish. Okay. Okay. And less than means everything to the left. Okay. So here we're just given one boundary value. The left boundary value is negative infinity, and then it goes up to whatever this z-score is. So let's find our z-score for 7 hours. We know it's going to be negative because it's to the left of the mean. So 7 minus 7.8, so it's 0.8 away from the mean. 1.3 is the standard deviation, so it's going to be less than 1 standard deviation. 7 minus 7.8, negative 0.8, and then divide by 1.3, and we get negative 0. We're going to round that to 6.2, equals negative 0.62. So we want the area, we could say to the left of, I think the calculator says below, so below negative 0.62. Okay, so let's go to the calculator. Okay, so now, again, we have above or below, so I'm going to click on below, the button, okay, and change this value to negative 0.62. Okay, and then I'm going to click recalculate. I'm looking at the picture. That looks correct. It's everything to the left like we wanted, and we get the areas as a percentage, 26.76%. 27.76%. I apologize. This is 26.76%. I forgot when we flip screens. Let's look at the next one. So this is going to be phrased a little bit differently, but we're still going to compute in the same way. So it says, if a student is chosen at random, what is the probability that the student slept more than 10 hours per night? Okay. So this curve is also a probability distribution. It has an area of 1 or 100%. These are all the things that can happen. Okay, and if we find the percentage that's above 10 hours per night, that's going to give us the probability that a student would sleep more than 10 hours per night. So 10 looks like it's about here-ish. Okay, it's a little bit to the left of 2 standard deviations, and we want this area right here. So first let's find our z-score. So for 10 hours, we just have one boundary value, and then on the right it goes forever. So we have 10 minus 7.8 divided by 1.3. Well, the difference from the mean, it's 2.2 away from the mean. And how many standard deviations is that? Well, it's going to be between 1 and 2. Let's divide by 1.3 to see. And we get 1.69 is the z-score. I never wrote z, so z equals 1.69. So we want the percentage above the z-score 1.69. So let's go to the calculator. I'm going to change this from below to above. And I am going to change this to 1.69. Oh, do I have to backspace first? There we go. 1.69. And I'll click recalculate, and notice it matches our picture, and the area is 4.55%, and that also corresponds to the probability. think it's at 4.55%. Now in this last one, we're asked if a student is chosen at random, what is the probability that the student slept less than 4 hours or more than 11 hours per night? Okay. So we call this the tails of the distribution. We call these pieces tails. Okay, and there's a left-hand tail and a right-hand tail. And this is going to be two separate areas. So notice I circled or because it's not both less than 4 and more than 11, because none of them are. Okay, we want these two pieces. So 4 hours is about here, so whatever this area is, and 11 hours is about here, whatever this area is, and we want to add these two areas together, which the calculator does for us. Okay, it has a special button for finding these. So first let's find our z-scores. So we have 2 for this problem. So for 4 hours, we have z equals 4 minus 7.8 divided by 1.3. So that is 3.8 below the mean. And how many standard deviations is that? Well, we divide by 1.3 and we get negative 2.92. Now for 11 hours, our z-score is 11 minus 7.8 over 1.3. So the difference from the mean is 3.2. And how many standard deviations is that? 2.46. And that one's positive. Okay. So now let's go to the online calculator. Okay, so notice it has this one that says outside. And if you click on outside, notice it has the two pieces in the tail. Now we put the smaller or the negative value, so work from left to right here. So this is negative 2.92, negative 2.92, and then this upper value was for 11 hours, which was 2.46. Okay, now I'm going to click recalculate. Okay, notice that area was smaller. This one's a little bit bigger. In total, we have the area 0.0087. So as a percent, multiplying by 100, that's 0.87%. So 0.87%. Okay, so that's very small. That makes sense because that's people who barely sleep and people who sleep more than the average amount of sleep.